This was something that when I was talking to Dr. Otwin Hess, he did go quite deep into talking about the sustainability issue for energy required to support the quantum technology as well as the AI domain. And going a little further upon that, what currently are the what currently is the work being done in the sustainability field, like whatever you are familiar with, to make sure that this sort of energy crisis in regard to fueling these technologies is being met or dealt with.
Oh, okay. With regards to, like, let's talk about the classical part. I think many companies, many institutes are working towards this, making chips which can actually run AI in a very power efficient manner, uh, or like having the ASICs or things which is just there for this kind of a processes and are able to save a lot of energy in this aspect. So this is a one aspect which I see is going on. The other aspect which I talked about is the quantum thing which should work in. Yeah.
You also mentioned two things that I would like to talk to you about a little more. First of all, you said that you always had an admiration for mathematics, and I personally believe that, and you'll agree, of course, that maths is the fundamental platform or the backbone of all these technologies, especially AI, which is or deep learning, which is entirely dependent upon the models that are built using mathematical concepts and frameworks. My question to you is, how are these models built from the complete scratch using maths?
Okay. Uh, so I think I could answer this in a very very basic format. Is like, there is a given x is our input. Okay, and what I said before is that we need an f of x to find out. We need a function that basically tells us that what exactly our f of, let's say, x1 value is. It has to predict what of x1 value is. So we are devising algorithms based on that thing. So let's say when we come to a a simple linear regression problem, what is this is what a mapping is. Then a back propagation is again a loss function which we are trying to optimize. There is where again the math lies, where we're trying to imagine that a given model, how does it has to go ahead based on the input, and what parameters it exactly has to update, so that it achieves the given f of, let's say, x1 value of it. So that's the main motivation behind going from like an input model, like for the AI. So this f of x could be like anything, and the AI role is to approximate what this exactly f of x is. And people are utilizing this f of x in various formats, so that they can like build multiple f of x and then like uh, have a given output. So yeah, I'm just explaining this thing in a very vague manner. I'm just not able to come up something in my mind in which I could just explain you in a very deep format right now. So yeah.
But I mean, what I think that you'll be able to give some really good advice about is, how can people get better at mathematics? How can they strengthen their fundamentals in order to finally be able to pursue research in the area of machine learning or deep learning, where they are actively required to utilize the concepts of maths to build such frameworks?
Okay. So I'm not an expert in math, I would say, but as a person who likes math, who likes doing math, people should like not just adhere towards the fact of outputs or how the whole algorithm works. It's like really understanding the math. It's like trying to do, okay, now if this is my input or this is my x, how this f of x is actually being built upon, or how this process is going to take place. Can I do it on paper? Okay, if I am saying an SVM algorithm, oh, okay, so given my inputs, can what is how can I just have an soft core margin, hardcore margin, and stuff? For what exactly the equations are at? Then you can just understand. Oh, okay, this is how it is working, so that you can just get into all of these things. So yeah, so in this thing I would say like my professors also did play a very vital role in making me understand on like how it's not just the programming, it's the math and the programming. So I think people should go ahead with understanding through like trying to solve it by themselves. It is difficult, it's not easy, but once we get a knack of it, it becomes very intuitive later on how things are going to work later.
You also, the second thing that you talked about was quantum machine learning.
Hmm.
How does this work? Like, if you had to give a complete breakdown of the entire rigor that goes to develop quantum machine learning, what is it? Like, explain to me the entire process for somebody who's got no context about it. Like, for the listeners who are novices or amateurs in this field, what is it really?
Okay, exactly. So quantum machine learning right now, what the trend goes in is like putting on the machine learning algorithms on a quantum platform or using quantum operations to do so. So I'm assuming right now the public knows what an artificial neural network is and what quantum gates are. So if in that regard, so there are something known as a parameterized gates, uh, and there is something called as an unitary in quantum computing. So a and parameterized unitary is something which acts as a function for us in a quantum machine learning model. The way I was telling AI that there is a function f of x, so in here in regards it comes of u of theta. The and in our quantum machine learning part, we try to approximate this u of theta. Okay, so we are trying to understand what an exact unitary would be. So given an input, we will have a given output. So what this u of theta could be? It tries to learn by itself. So this is a simple trend which is going in quantum machine learning, but this is not complete quantum machine learning. There are various different methodologies that are working. This research is very going ahead. There is a lot of things that are working in. Simply, I could say like we one could even explore in the exactly the encoding techniques. How can we encode a classical data on a quantum data? There are few encoding like amplitude encoding, phase encoding, and stuffs, but what is the one which is really helpful? Then what exactly kind of a unitaries are really required to do so? What methods are there? It's like we it's easy to assume that there exists an f of x, but we don't know what kind of a format this f of x could be. So that is the whole research that goes on. Okay, so yeah, so answering the question at the end, at what exactly
Hmm.
quantum machine learning is, it's in a very simple term, it's understanding what an u of theta is and then optimizing the theta parameter to make it learn what the approximate function in a quantum machine learning model. Yeah.
Two major things that either of these technologies, may it be machine learning algorithms or deep learning frameworks, that they are utilized for are generally optimization challenges and pattern recognition.
Hmm.
What is the current, or what are in general the applications of these problems? Like, if you had to define optimization problems or pattern recognition issues for somebody who is not able to comprehend the actual real world application of these, could you give a real world parallel of them, and then how these algorithms are utilized to actually solve them, that process.
Oh, okay. Okay. Let me start with the optimization part. Let's say you want to go from a place A to place B. Okay, and uh, okay, let's say you are in Mumbai and you want to go from like Powai to, let's say, Dadar, and now you don't actually, and there are multiple ways to go there. There are multiple routes to go there. So right now, what would be an optimized method to do so? Is something which an AI problem could solve, something which a quantum computer could solve. Finding the shortest way is what an optimization is. As a utility, a company could be like, let's say, Uber. Uber is going to use this kind of an algorithms to leverage that, oh, there are multiple drivers who just want to take you from place A to place B, but which is the correct person, or which is the correct driver, so that it is optimized not only for you but also for the driver to take you from place A to place B. So that is an optimization problem that is there. And in the pattern recognition thing, it is again understanding, classifying that what kind of the drivers are, basically like what kind of a pattern they see. Oh, there are like, oh, there is a particular driver that actually is around, it stays from that area of one, let's say, the which I say the Hawaii, and there's the other, so that he travels there. So classifying that, okay, these are the certain numbers of drivers which actually commute from place A to place B, or is feasible for them because their home is nearby, or maybe they prefer because of there is less traffic, which is not the case, but yeah, that's usually how things works on. So I don't know if this is a very good example, but this is something which is coming in top of my mind right now for an optimization and pattern recognition, where it tries to understand, because with things in life, many things in life just goes under like a certain patterns we see, and these patterns are not completely repetitive, but mostly are repetitive, and we can just estimate this.
Also, the mathematics or the theory behind building this, actually, from a programming point of view.
Okay, in the programming point of view, so basically we use so mathematically one would start with linear algebra, given an x input, and there is again the f of x. So now what we are trying to find out, let's say there is a linear function that's like f of x is equals to ax1 plus bx2 plus cx3. That is, the whole function is depending upon the three inputs, the x1, x2, and x3. Now we need to find exactly what the values of a, b, and c are, so that we can actually define an f of x. So it's like, given any input of x1, x2, and x3, uh, I will have a proper f of x value. It's like a, a graph, and in a graph I just want to draw a straight line. Maybe not a straight line, it could be a curved line or something, but for simplicity I'm just telling you there is a straight line that is existing. So I know there are a few points in my graph, and in these few points I can try to estimate the coefficient which are responsible for actually stating how the line goes. So given there is another input value, how good it could estimate this. So in the programming perspective also, you can just program such an equation using Python. Very simple. So yeah, so the whole thing starts from here, and then the different models are built upon like this basic concepts.
Uh,